So we're going to finish 7.4 today. A little bit more, taking a look at what we kind of did, and then jump into 7.5, and that'll put a wrap on chapter 7. And as you know, we're only doing a little bit in chapter 8. So as I said earlier, we have 5 classes left. We're coming down the home stretch. Last class, we started working with these things called vectors. Working with vectors, and it comes back to, if I want to talk about a vector, it was a directed line segment, had an initial point, it had a terminal point, it had a magnitude, right? It had an angle associated with it, a directional angle. And these guys actually come into play in your physics courses and a lot of other courses. Again, math is a sister course to everybody, sister discipline. You use math you use statistics when you're going into nursing, you use trig when you go here, just all over the place. So we were talking about those guys, and one of the things mentioned was these single bars represent the magnitude, and the angle measure is theta. And we also talked about how, given these two things, I'd like to come up with what are actually called the horizontal and vertical components. And somebody might be going, what? And I'm going, yeah, that's less than symbol A, comma, B. When I write a vector, I don't use braces or parentheses, but I use these guys right here. And I think somebody called them diamond brackets somewhere along the line. So in this first problem, I'd like to calculate what the horizontal and vertical diamond operators. Yeah, thanks, Patrick. We just talked about that. I told you I forget it quick. And then the second question was, what about if I have my horizontal and vertical components, 3, -2, how do I get the magnitude and how do I get the direction angle? I'm going to pause. I'm going to let you think about these two and see if you can go, yep, I got 7.4. I'm pretty happy with that. So now, what are the horizontal and vertical components? And Chow was putting some answers there. Again, I'm like, I don't remember, holy cannoli, but I've said it maybe once or twice. What if I drew the picture and I get ready and say, I have an angle measure of 60. There's my 60 degrees. I have a magnitude, right? I have a magnitude of 5, and I'm looking at this saying, okay, this guy right here ends at that A, comma, B. And hopefully if you did that and you drew the picture, oh yeah, no, wait a minute. I got something going on that looks like this. Here's A, here's B. And all of a sudden I can say the cosine, yeah, cosine was always associated with that first number in my ordered pairs, or again, this is talking about vectors, putting them on Cartesian coordinate system instead of having them just floating in there somewhere. So yeah, I had the cosine of 60 degrees equaled A over 5. And the sine of 60 degrees equals B over 5. And again, I could say A equals 5 cosine of 60 degrees. B equals 5 sine of 60 degrees. And deriving it, I'm good with deriving it. This to me is good. Some people remember A is going to be the magnitude times the cosine of theta. B is going to be the magnitude times the sine of theta. Yeah, well, yeah. I drew the picture and used some stuff that I've learned earlier in the semester and applied it to my vector. Five cosine of 60. Big girls don't cry. Big girls don't cry. Sorry.
2.5.
2.5?
No, it's on the top. 5 cosine 60.
Yeah, that's my A. That's my horizontal component. Does this become 2.5?
Yes.
Boom. B is 5 sine of 60 degrees.
4.3.
4.3. And if I look over here, if this comes 2.5, that's 4. Yeah, I'm okay estimation wise, making sure, checking my answer, and I'm happy with that. I am happy with that. Okay, so in the same respect, calculate the magnitude and the direction. I'm drawing my triangle again. I need to find my theta right here. I'm given 3 as my horizontal. Oh, hold on, Babalu. We need the eraser. Squish, 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 squish. I got excited, but I didn't really look so much at the problem. I have 3, 1, 2, 3, -2, and there is my vector. Has a, yeah, it's got, yeah, okay, yeah. My vector is 3, -2. I know this is 3. I know this would be -2. I need to find theta, and I need to find the magnitude. Now, what's the magnitude? The magnitude of this is going to equal, that's my distance formula. The magnitude squared equals 3 squared plus -2 squared. The magnitude equals the square root of 13. The angle measure? Sure, no problemo. Tangent of theta, I'm going to use tangent, equals -2/3. Theta equals the inverse tan of -2/3. Yay, theta equals. Theta equals, man, you're too lazy to get your calculators out, aren't you? Inverse tan of -2 divided by 3. No, I did the tan, the inverse tan. No wonder my answer looked.
I got 33.69. I don't know if that's
okay. Did you get -33?
Yes, I did. Yeah.
Yeah, because it's got to come down here in the 4th quadrant, and -33.69 is acceptable. I could take 360 and subtract it from that to make it a positive number. I just need to make sure it's in the 4th quadrant. All right, now we get into goofiness. Yeah, oh boy. These are problems where you start to need to do them before you kind of, but hopefully you got the math down before, you know. Okay, before you start. 2 forces of 15 and 22 newtons acting on a point in the plane. Well, here's my point on the plane. Okay, that's pretty good. A newton of unit is a force that equals 0.225 pounds. It's in parentheses, so I'm thinking that's just a fact that's quoted there. If the angle between the forces is 100 degrees, right here, calculate the magnitude of the resultant force. So here's 15, here's 22. They're pulling at each other 100 degrees. Yeah, I want I want to find the magnitude of V. I want to calculate right there, the magnitude of V. Magnitude of V. By the way, if you don't feel like writing all this down sometimes, it is okay to just do screenshots and save the screenshots. Gianni, go ahead.
Does that little red is that a 90 degrees, like the little right under this one?
So talking about that right now, this is a parallelogram. Okay. So if this is 100 degrees, this angle has to be supplementary, has to add together to give. So if I did a square, what are each one of these angles?
90s.
90, right? And it adds up to be 360 degrees. So if I tilted this or smushed it or whatever and made a parallelogram, I still have to have the sum being 360. So if this is 100, this is 100, this guy would have to be 80, and this guy would have to be 80. Okay, these two end up being what we call supplementary. They add together to be 180. So the long answer to your question is that's 80. All right, so I drew the picture. I put in as much stuff as I could, and I'm kind of stumped. So I'm going to take this idea and I'm going to back it up. Back it up. I'm going to, yeah, I have this 22, I have 15. I know this is 80. Not sure what that ended up to be, kind of deal. But, and again, I want to be able to calculate V right here. So I'm going to go back to what I've learned before. And I got really, this A equals, here's B equals, here's B. I know that's 80. And here's C. I don't know that. I don't know A. I don't know C. I know that this is little a equals 15. This would be little c is 22. And I want to calculate little b. So this is crazy. I drew it, and then I'm going back to, hey, wait a minute. I'm going to write this out as A, I don't know. B, I know is 80 degrees. And C, I don't know. Little a is 15. Little b is what I want to calculate. And what else do I have? Little c is 22. If I look at what I'm given, can I solve this? I want to find the magnitude. I should have put bars in there. The magnitude of that vector. Oh, this looks like solving my triangle, doesn't it? What am I going to use here? Do I have 3 pieces to do the law of sines?
Law of cosines.
Yeah, I'm going to have to use the law of cosines. And this is what I want to calculate, this b. So, I'm going to say b for right now, but I know b is also the magnitude of that vector, which is what I want. I believe I'm going to go b squared equals a squared plus c squared minus 2ac, the cosine of b. I have a and c and angle b, a and c and angle b, and I'm good with all that. Nice. B squared equals a squared. I'm going to just put in 225. C squared. What's 22 times 22?
484.
Exactly. Minus 2 times A times C. And again, this is where you practice math in your mind. You need to keep doing math so you get better at it. 2 times,
720.
what'd you get?
720.
720, 2 times A, that's 30. 30 times 22, I get 660. Anybody else get 660? 2 times 15 times 22. That's 30 times 22. There's the
Yeah, that's
zero.
60.
660. Okay.
660.
Times the cosine of 80 degrees. V squared equals, I can use my calculator. Oh, that's me being funny again. And let's see.
8.5, I think.
What'd you get?
8.5.
8.5 for all of this. 8.5.
So how many certificate significant you have? You want 3 or 2?
Usually 3. So I'm gonna go 225 plus 484 minus 660 times the cosine of 80. And
never mind. That's the what?
594.392. 594.392. Now I'm going to take the square root of that answer. 24.38. So B equals 24.38, which is really the magnitude of that vector. I just used other trig that I knew. This part up here stank. Once I got to here, I was good. So this is part of what trig is about, teaching you how to do all of this. So when you get a problem and it's set up, the sister discipline known as math kicks in and you're able to solve that. So that V, that resultant vector, should be 24.38. And if you think about it, yeah, that's my diagonal. It should be bigger than both of these. And yeah, I kind of like that. All right, any questions? Any questions? Gianni.
So could you technically find the inside of those angles though? Because you see how it says like 100 degrees there? Wouldn't that split in half and be 50 and 50? Or would that not?
Well, if it was a 90-degree angle, it would technically be cut in half. Yeah. Could I find it? Heck yeah. I just calculated little b to be 24.38. And if you needed to find those angles for some reason, here you go. You know, we could find what this angle is I'd use the law of sines to find out what angle C is. And again, I'd use the law of sines to count. Well, once I found one, I would do 180 minus 80 minus, and then get the last one. So it would be completing the triangle like we've been doing. Yeah. But yeah, no, they're not really cut in half. Good thought, though. Cool. Last section in chapter 7. I need to make sure I go a little slow here because I already have a lot of the writing done and it would be easy for me to go really quick. Okay, so vectors. I have a vector AB. And if I add another vector to it, I just straight up add the values. If I come down here, vector U plus vector V equals -2 plus 4, which is 2, 1 plus 3, which is 4. I just straight up add the vectors. We've already talked about a scalar, some numerical value. And if I'm to multiply that by the vector, it's just like distributing. If I said -2u, I'm going to get 4, -2. We talked about the opposite vector. I have vector A and it goes certain horizontal and vertical components, then -A would be the negative of those two values. This actually goes back up to being a scalar, where my scalar is -1 times the vector. And just like we have addition, we also have subtraction. We're going to subtract the horizontal, and we're going to subtract the vertical components. If I wanted to combine all those, 4u minus 3v would give me, first of all, -8, 4 minus 12, 9. And it looks like I'm going to get the vector -20, -5. That's not too shabby. Any questions up to that point? I'm going to give you another 30 seconds to make sure you have all that written down. Unit vector. A unit vector is a vector that has a magnitude of 1. This is one of those things, it's a building block for something that's coming up down the road in another math class, in a physics class or so forth. But a unit vector is one, as I said, it has a magnitude of 1. There are 2, and they even get their own letters. I is the unit vector 1, 0. J is the unit vector 0, 4. All vectors can be rewritten, with their unit vectors. And now you're going, ooh, that was good to know. But you heard it, and it may come back where you have to say, wait a minute, I need that unit vector. Here's what's one of the main important things from this section. We did all the algebra. Now we're going to take a look at something called the dot product. And this is applications that will come in down the road that will need the dot product. I have a little note over here. It's also called the inner product sometimes. So this is the dot product. When I'm dealing with vectors, I can't multiply them. But there's something called the dot product that will result when I say, what is the dot product of vector u and vector v? The dot product ends up being a number. I take horizontal times horizontal plus vertical times vertical. This gives me a number. So when you're doing the dot product, you're going to end up with a number. Some folks will end up with another vector somehow. No, oh boy, no idea what's going on. So if I said, what is the dot product here? I'm thinking it's going to become 8 plus -3, 5. What is the dot product here? -12 plus 12, 0. Oh, that's cool. The dot product between 6, 4 and -2, 3 is 0. 6, 4. Let's see if I can do this without messing it up. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4. And if I draw that, that's cute. Yep. And the other one is -2, +3. 1, 2, 3. And I draw this one, I get that result. If the dot product of 2 vectors becomes 0, these 2 vectors are perpendicular. Perpendicular. Another word that you're going to hear is orthogonal. And what you have is when the dot product is 0, I get a 90-degree angle. Huh. That's interesting to me. What do you think about that? The dot product results in a number. I get different numbers, but if I happen to get the number 0, these two vectors are perpendicular. Nice. Properties of the dot product. Just like we had the algebra earlier, we're going to have some things going on with dot product. I had a course in grad school that we would have to take, we would learn a new topic, some sort of mathematical thing like the dot product, and we had to go through and prove each one of these before we could use it. This is the commutative property. U dot product V equals V dot product U. Here I have U dot product V plus W equals, that almost looks a little bit like the distributive property. So I'm allowed to do that with dot products. Here's a scalar K. I can take K times vector U right away, then the dot product. Because remember, we don't have multiplication. We have scalar multiplication, but not multiplication. That's the dot product. Equals, I could do the dot product first, or I could send the scalar over to V first. It can slide all over the place inside of there. Zero dot product U equals 0. Yeah, if I took 0 times each of the components, they would end up being 0. Ah, look at this. U dot product U equals the magnitude squared. Huh. Remember, these bars are called the magnitude. So if I took the dot product of something times itself, I would get the magnitude squared. Okay. It's going to be a test question. I can almost guarantee it. What is the angle between two vectors? We're going to get that question. What is the angle between two vectors? Well, it ends up being the dot product, we say, is equal to magnitude of U times magnitude of V times the cosine of the angle between them. So if I'm given two vectors, vector 3 and vector 3, 4 is my first one, and my second vector goes to here, and I wanted to calculate the angle between those two, this is how I would do it. So you're going to get a question, calculate the angle between two vectors. And here they are. Okay. It comes from this guy. This one, I just brought the magnitudes down underneath. Okay. So I want to go ahead and calculate that. I'm going to say the cosine of theta equals the dot product, U dot product V, over the magnitude of U, the magnitude of V. Dot product. 3, 4, dot product with 2, 1. 3 times 2 is 6, plus 4, I get 10. The magnitude of U, here's V. what is the magnitude of u? I got this. It's going to be the magnitude of u is going to be the square root of 3 squared plus 4. Oh, that's not squared. 3 squared plus 4 squared. The magnitude of v is going to be the square root of 2 squared plus 1 squared. This one's easy. That's 5. This one looks to me like it's going to be square root of 5. I'm excited. I'm going to clean this up. 2 over the square root of 5, 2 square root of 5 over 5 kind of deal. Almost there. Theta, I need to block that out, block that out. Theta equals the inverse cosine of 2 square root of 5 over 5. Theta, I don't know where to write it. I'm so excited. Theta equals I'm doing all the work again and I don't like it. The inverse cosine of 2 times square root of 5. Get out of that. And then that I want to divide by 5. I'm sorry?
I got 63.434. Yeah.
Uh-oh.
I don't know if that.
I got 26.565. I'm going back and look at my picture. My picture is that angle right there. I'm thinking it might be 26 because it's a little smaller. Did you do the, all right, I'm double checking me. The inverse cosine of parentheses 2 times square root of 5 divided by 5. Anyone else?
Uh, 26.56.
Okay.
Did it again. I did it your way. Yeah, you're right.
You had a little too much square root going on up there?
No, yeah, so I did it before, and so I did 2 times the square root of 5, and then
Right.
I divided by 5, and then I did the cosine, and then I just typed it in. But yeah, I think I messed it up somehow.
Yeah, okay. So theta does in fact equal 26.565.
Yeah.
Cool. So it wasn't a lot today, but it was kind of a lot that we put in there. And I don't know if you want to sit and do more problems. We can always do that. But that would be the end of the lesson for today. If you want, you can go do that evaluation. There's plenty of time right now. Or you could go and rate my professor and put something down there. That would be, I don't know. I never really tell students to go do that.